This week in GESM 160, we will focus on levels of measurement, reliability, and validity. This is part 1 of the recorded lecture for week 8. Let's begin by talking about variables in measurement. How would you define these two? Variables are anything that can take on more than one value. They can be quantitative, such as test takers' age or income. Variables can also be qualitative, for example, a test taker's gender, ethnicity, or self-efficacy. Measurement, on the other hand, is the assignment of labels to a variable or an outcome. In other words, once we measure a variable, we can assign a label to it. For example, the number of students in a class, a student's score on the last quiz, or how much time it takes to bake a cake. The purpose of tests is to measure variables and make inferences about what this measurement means. In 1946, a famous experimental psychologist wondered if we could make more accurate inferences about test outcomes if we measured variables more precisely, or classified the types of variables we measured. This inquiry is where the 4 levels of measurement are derived. A level of measurement represents how much information is being provided by the outcome measure or variable. There are 4 levels of measurement in order of least precise to most precise. They are nominal, ordinal, interval, and ratio. On the next 5 slides, we will discuss these different levels. We'll start with the level of measurement that gives us the least amount of information, the nominal level. The nominal level of measurement describes a measurement system where there are differences in quality rather than quantity. This level is categorical in nature in that it names which category an outcome score can be placed. These labels are always mutually exclusive. An outcome cannot be in more than one group. Lastly, variables that are at the nominal level of measurement are always qualitative. Let's pretend that a survey has been conducted to collect some information about undergraduate students at USC. Suzanne and Daniel both filled out the survey and offered information at all 4 levels of measurement. At the nominal level, these participants named their undergraduate major. Suzanne is majoring in business, and Daniel is majoring in cinematic arts. Notice that the only information given here is the category of study or major. If we want to know further information, we have to measure variables more precisely. The ordinal level of measurement describes how variables can be ordered along some type of continuum. That is, with the ordinal level of measurement, categories are ranked. This level is more precise than the nominal level in that it puts the categories in order, but it is less precise than the interval and ratio levels. Going back to our 2 survey participants, an example of a variable measured at the ordinal level is class rank. We found that Suzanne is a junior and Daniel is a sophomore. The interval level of measurement assigns a value to an outcome that is based on some underlying continuum that has equal intervals. So with this level, the variable is named and ordered, but the difference between the categories is equal. This allows for a specific interpretation as to someone's position, that is, his or her score, relative to another person's position. Continuing with our make-believe survey, one of the questions asked how many units each test taker had completed. It turns out Suzanne has completed 68 units, while Daniel has completed 62. It is very obvious that this information is much more detailed in nature than the ordinal question in the previous slide. Even though Daniel is still a sophomore, he is only 2 units away from being classified as a junior. In the previous slide, we may have inferred that Suzanne had completed many more classes than Daniel, but it turns out they are not even a semester apart. The interval level of measurement is very important for our class, not only because of the big jump in the amount of information it supplies, but because this is the most frequently used level of measurement in the social and behavioral sciences. In other words, the interval level is critical in being able to compare variables such as self-efficacy and learning outcomes in educational psychology. Lastly, we have the highest and most precise level of measurement. The ratio level of measurement includes all other characteristics from the nominal, ordinal, and interval levels, but in addition also includes an absolute zero. This means that there is absolutely no amount of a trait or characteristic present. This level is almost never used in the social and behavioral sciences because it is difficult to think of any trait or characteristic that a person can have a complete absence of. For example, while a person may be very outgoing, there will still be circumstances where the individual may be shy or more reserved. For this reason, it is very difficult to ask a ratio level question of our pretend undergraduate students. Maybe the number of dance courses they have completed would work if they had 0 dance courses, but we have to be careful not to imply that they have 0 dance ability. In wrapping up our discussion about the 4 levels of measurement, keep in mind these 4 questions that the different levels can answer. How much of the available information are you measuring? Can you assign a name to the variable being measured? Can you assign an order to the variable being measured? And can you assign an underlying quantitative scale to the variable being measured? These questions will help you determine in which level of measurement a variable belongs. Next, we will move on to a discussion about reliability. Reliability is whether a test or measurement tool measures something consistently. A test is reliable if it consistently produces whatever observed score a person would get on average, regardless of whatever it is a test is measuring. There can be variability in an observed score due to the amount of error in the score. Let's take a look. According to the classical model of reliability, we calculate an observed score by adding the true score and the error score. There will always be error in a test score, which means a true score can never be produced. It is only a theoretical reflection of the actual amount of trait or characteristic possessed by the individual taking the test. But the closer the true score is to the observed score, the more reliability a test has. And again, this all depends on the amount of error there is in a score. So what causes error? There are 2 types of error, trait error and method error. Trait errors are derived from the test taker, such as not studying enough, being preoccupied by another event while taking the test, or even not getting enough sleep the night before. Method errors result from the test-taking situations, such as ambiguous test instructions, an uncomfortably warm or cold test environment, or even someone next to you engaging in disruptive behavior. Ultimately, we want to reduce the amount of error on a test so we can increase reliability. There are 4 different types of reliability: test-retest reliability, parallel forms reliability, internal consistency reliability, and inter-rater reliability. Test-retest reliability, or time sampling, examines the reliability of a test over time. This type of reliability is important when you want to examine differences or changes over time, and thus runs the risk of having the first testing influencing the second testing, or normal growth or development making the test appear less reliable. Parallel forms reliability examines the equivalence or similarity between 2 different forms of the same test. For example, there are several different versions of the SAT, but in order to be reliable, the different forms cannot be any more or less difficult than the others. Internal consistency reliability examines whether the items on a test represent one and only one dimension, construct, or area of interest throughout the test. This type of reliability is dissimilar from the previous 2 forms, as it measures whether the items on the test are consistent with one another, as opposed to over time or with another version of the test. Inter-rater reliability examines the consistency of individuals administering or scoring the test. For example, if there were 2 sections of the same course taught by 2 different professors, it would be important that an A on the midterm in one section is consistent with an A on the midterm in the other section if both professors are administering the same test. When determining the inter-rater reliability, we calculate the proportion of the number of agreements between different observers or scorers to the number of possible agreements. A correlation coefficient is a numerical index that tells us how much 2 variables have in common, or how much they are related to one another. When calculating reliability, correlation coefficients can be between 0 and +1. The closer the correlation coefficient is to +1, the more reliable the test. The Pearson correlation coefficient is used to compute test-retest reliability and parallel forms reliability. The Spearman-Brown correlation is used to calculate internal consistency reliability because of the nature of how this type of reliability is measured. Since we are measuring the test in relation to itself, we have to split the test in half and compare the different halves of the test. We do this by comparing the odd-numbered items to the even-numbered items, but in splitting the test in half, we reduce reliability since a test with less items is less reliable. The Spearman-Brown correlation corrects for this issue. Cronbach's alpha can also be used to determine internal consistency, and it is especially useful when looking at a test where there are no right or wrong answers, such as a personality test or a test measuring someone's self-efficacy in a particular course. Cronbach's alpha compares the score of each item with the total score for each individual, and then takes each of these calculations and respectively compares them to variability present for all individual test scores. Lastly, the Kutter-Richardson formula is used to compute internal consistency reliability for tests that have right or wrong answers, such as a multiple choice or true-false achievement test. Next, we'll take a look at validity. Validity is the property of an assessment tool that indicates that the tool measures what it says it measures or does what it says it does. For example, if the assessment says it is a measure of personality, then it should not measure other variables such as mood. Or on an achievement test that is assessing a test taker's ability to calculate reliability, you wouldn't expect an item that asks for the test taker to explain the causes of the American Civil War. An item such as this would not be valid on a test that is supposed to measure if a person can calculate correlation coefficients. As you can probably see, without validity, the outcome of a test would be meaningless. When we receive test scores, we make inferences about what the test means. If you receive a high score on a test measuring your understanding of the information processing theory, you can assume that you have a strong understanding of that theory only if the test is valid. So how do we measure validity? While there are quantitative measures of validity, for the purposes of this course, we are more concerned with the external evidence that exists, such as comparing a test with other similar tests that have already been validated, or ensuring that what is being assessed is aligned with activities that were used to teach the content of the test. There are three types of validity: content validity, criterion validity, and construct validity. Content validity is the property of a test such that the test items sample the universe of items for which the test is designed. This type of validity is most often used for achievement tests. For example, if you were taking a test on the information processing system that only asked about working memory, this would be an issue with content validity. If the test is supposed to measure a test taker's understanding of the entire system, questions should not only address working memory, but also sensory memory, long-term memory, and the functions of each. When we are trying to establish content validity, we have to ask ourselves, does the collection of items on the test fairly represent all the possible questions that could be asked? Criterion validity assesses whether a test reflects a set of abilities in a current or future setting as measured by some other test. This type of validity is most often used for achievement tests and certification or licensing. Concurrent criterion validity examines how well a test outcome is consistent with a criterion that occurs in the present. For example, if you've ever taken the behind-the-wheel test to get a driver's license, your ability to drive was being measured against an established criterion that was probably on the clipboard of the examiner next to you. Predictive criterion validity examines how well a test outcome is consistent with a criterion that occurs in the future. For example, the GRE is supposed to predict how successfully students will perform in graduate school. Lastly, construct validity examines how well a test score reflects the underlying construct. A construct is a group of underlying variables. For example, if you were to measure a person's motivation, you might choose variables such as self-efficacy, goal orientation, values, personal interest, or attributions. Because these concepts are not easily defined, this type of validity is particularly difficult to determine. Now that we've taken a look at reliability and validity separately, it is also important for us to understand how they relate to each other. Reliability and validity are close cousins. Validity wants to know what's being tested, and reliability wants to know how consistently it's being tested. Also, the maximum level of validity of a test is equal to the square root of the reliability of the test. Thus, a test's validity is limited by its reliability. Another way to look at this is that a test cannot be valid unless it's reliable. This illustration may help to better explain the relationship between reliability and validity. The picture on the left illustrates both reliability and validity. It is valid because the arrows are hitting the center of the target, and reliable because this is occurring repeatedly. In the middle image, the arrows are consistently hitting the same place, so there is reliability, but because they are not in the center of the target, there is no validity. Lastly, in the picture on the right, there is no reliability or consistency, and thus there is a lack of validity. Finally, as you are studying for the quiz this week, practice answering these questions. What is a variable? How are the 4 levels of measurement similar and different? What is reliability? Explain the 4 types of reliability. What is validity? Explain the 3 types of validity. How are reliability and validity related?